Welcome. Dear students, today we are going to discuss on Anti-Markovnikov rule. What would happen if an unsymmetric reagent reacts with an unsymmetric alkene? I repeat, what would happen if an unsymmetrical reagent reacts with an unsymmetrical alkene, and that too in the presence of peroxides? What would happen? As an example of an unsymmetrical reagent, I take HBr, and as an example of an unsymmetrical alkene, I take the simplest of all unsymmetrical alkenes, which is prop-1ene or simply propene. Now propene is the simplest of all unsymmetric alkene and HBr is unsymmetrical reagent. Now I react them in the presence of peroxides, and I also apply UV light or UV radiation. The UV radiation is a very high frequency radiation. It is very energetic, and what it could do is it could knock out the electrons of the peroxides and split them into two peroxide free radicals. Split them into two peroxide free radical. Now what would the peroxide free radical do? The peroxide free radical has a free electron. It is only having one electron. It is deficient of one more electron. So what it can do is it can split this into two equal free radicals. So it splits it into H free radical and Br free radical. Now the H free radical here, it is deficient of one electron. It has only one electron. It is deficient of one more electron. What it can do, it can go and attack the electron cloud of alkene. See, alkene has a sigma bond and a pi bond. The pi bond is actually a cloud right above and below the plane of the ring, and each pi cloud has two electrons. Our H free radical requires only one electron. It has two options. Either it can ask the one electron from this carbon atom, or it can ask that one electron from this carbon atom. Now the question is, from which carbon atom it would take that one electron, or to which carbon atom will it bind to? According to Anti-Markovnikov law, the hydrogen will go to that carbon which is having lesser number of hydrogen atoms. Let me repeat, according to the Anti-Markovnikov rule, the hydrogen goes to the carbon which has lesser number of the hydrogen atom. So accordingly, according to the Markovnikov rule, what product will be formed? What product will be formed? Yes, the product, the major product that would be formed will be N-propyl bromide. N-propyl bromide. That would be the major product that would be formed. And yes, a small quantity of isopropyl bromide will also be formed, but that would be very small quantity. It will be formed isopropyl bromide, but that will be very small quantity. It will be a minor quantity, but the major product that would be formed will be N-propyl bromide. Why? Because the hydrogen has chosen to go to a carbon that has lesser number of hydrogen atoms. Now the question is, why does the hydrogen, the main question here is, why does the hydrogen choose a carbon atom or goes to a carbon atom that has lesser number of hydrogen atoms? Why does hydrogen do that? Why doesn't it go vice versa? Why doesn't it go to the carbon which is having more number of hydrogen atom? Why doesn't it do that? But why does the hydrogen goes to the carbon which is having lesser number of hydrogen atom? To solve this question, we will have to look at the mechanism. Let us now go into the mechanism to understand this. Mechanism has 4 steps. Step number 1, dissociation of peroxides. dissociation of peroxides. Okay, so we are having this as peroxide. We apply UV light. Now UV light, as I said, it's a very high frequency radiation. It has sufficient energy to knock the electrons out of it. So we get 2 molecules of peroxide free radicals. 2 molecules of peroxide free radicals. Now the peroxide free radical is having 1 electron. It is deficient of 1 more electron. So it seeks to attack HBr in the next step. Let us see step number 2. Step 2, formation of bromine free radical. Formation of bromine free radical. You can write full. I have written just this. Now our peroxide, what it can do, it needs 1 more electron. It takes that electron from H and becomes ROH, and we get bromine free radical. We get a bromine free radical. Now dear students, what do you think? The bromine free radical will sit idle? Never. It is very reactive in nature and it needs 1 more electron to become stable. So that 1 electron it can get from the pi cloud of the alkene, of the unsymmetrical alkene. So that is what we are going to see in step number 3. Step 3, attack of bromine free radical. Attack of bromine free radical. Okay. Now what it attacks? What is the substrate here? Right, the unsymmetrical alkene, that is prop-1-ene, and Br free radical is the radical that is going to attack. Now it has 1 electron, it needs 1 more electron. This is the pi cloud. The pi cloud has 2 electrons in it. It just needs 1 electron. Either it can ask or it can attack this carbon atom for that electron, or it can attack this carbon atom for that electron, for that 1 electron, right? Suppose let us go for case number 1. It attacks this carbon atom. What would be formed? CH3, CH, okay, Br and CH2 free radical. Okay, this has taken its 1 electron. This carbon atom has taken its 1 electron. This carbon atom has taken its 1 electron. This carbon atom's electron it has shared with the Br electron, Br free radical electron, and they have made a covalent bond with each other, while this carbon atom still has 1 electron. Okay. Now consider case 2. What would be formed? CH3, CH free radical, CH2Br. So here also we are seeing that this electron, this carbon's single electron is shared with this bromine's free radical electron, and they have formed a covalent bond here, while this carbon's electron remains here. So that's how we get this one, and this is how we get this one. Now what is the difference between these two? Yes, this is a primary free radical and that one is a secondary free radical. Now here comes the main question: which of these is more stable? Is the primary free radical more stable or the secondary free radical more stable? Do you have an answer? Yes, dear students, the free radical is 1 electron. It is only 1 electron. It is deficient of 1 more electron. It is deficient of 1 more electron. In the case of secondary free radical, there are 2 R groups on either side. They can efficiently pump their electrons to this free radical and compensate for the deficiency here, right? In the case of primary free radical, pumping is from only one side. In this case, there is no efficient distribution of electron to this free radical. Therefore, secondary free radical is more stable because there is pumping from both sides, the electrons are pumped from both sides, and therefore the deficiency of one electron is somewhat compensated for in secondary free radical, while that is not the case for primary free radical where the pumping is only from one side. So therefore secondary free radical is more stable. It is more stable, and that which is more stable, its formation is favored more. That is, the formation of secondary free radical is much favored than the formation of the primary free radical. Therefore, secondary free radical will be formed in more quantities. So, let us now go for step number 4. Step number 4. This secondary free radical is actually a carbonium radical, right? It's a carbonium free radical, okay? Now let us go for step number 4. What is step number 4? Attack of carbonium free radical. Attack of carbonium free radical. Let's see. CH3CH free radical is here. CH2Br. It attacks another molecule of the reagent. It needs one more electron. That one electron it can take from H, and the major product that is formed is, yes, N-propyl bromide. N-propyl bromide. So this proves the Anti-Markovnikov rule, it is true that N-propyl bromide will be formed as the major product. Dear students, coming back to our first question. What was our first question? Why does the hydrogen go to the carbon atom which has lesser number of hydrogen atoms? Why does the hydrogen atom go to the carbon atom which has lesser number of hydrogen atoms? Coming back to this question, what is formed initially? Yes, secondary free radical is formed initially. Okay, before hydrogen free radical, actually bromine free radical is formed. Bromine free radical only attacks alkene, not hydrogen free radical. And when it attacks alkene, which is favored? Secondary free radical is favored. Why is it favored? Because secondary free radical is more stable than primary free radical. So more secondary free radical will be formed. Now in the next step, hydrogen free radical is formed. After secondary free radical is formed, in the next step, it is only in the fourth step that hydrogen free radical is formed. The hydrogen free radical has actually no other option other than to go to that carbon which has lesser number of hydrogen atom. So therefore, why does it go to the carbon that has lesser number of hydrogen atom? The answer is very simple. Because it has no other option, right? It has to go to that carbon which has lesser number of hydrogen atom, because bromine has already created the secondary free radical. Dear students, I hope you understood the class. If you like the class and if you have understood the video, please do not forget to subscribe the channel. Thank you very much.